All right, in this video, we're going to talk about element classes. So if you've got your guided notes open, we're on chapter 4 guided notes, where it says element classes. We talked about them last video. So I just wanted to start this video by reviewing what we learned in the last video. What is this first family called in the periodic table? Alkali metals. What about the second family? Alkaline earth. What do we call this big block of elements? Transition metals. What about these guys? The inner transition metals. Yeah, they should really fit inside there. Okay, then there was the staircase. What did we say if it was touching the staircase?
It's metalloid.
It's a metalloid or a semi-metal. They have properties of both the metals and the non-metals. And then we got over here to group 17. What do we call this family? Halogens. What do we call group 18? Noble gases. Everything above the staircase is a what? Non-metal. Everything below the staircase is a what? Is a metal. Except for who? Hydrogen. It's really a what? It's really a non-metal, but why is it over here then? It's got one valence electron, so it's in that column. Okay. That's a pretty good review of what we talked about last time. What we're going to do in this video is explain each class of elements a little bit more in depth. So let's get started. Okay, let's start with the alkali metals. It's the first group on the periodic table, so it's group 1. They have one valence electron. You need to know that. All of them have one valence electron. The alkali metals are never found in nature, are never found pure in nature. They're always with somebody else. And the reason for that is they're very reactive. They have one valence. So they're always going to try and give that electron to somebody else on the periodic table, and they're going to form a chemical bond, so they're always going to be with somebody else. They're never going to be found by themselves. The reactivity of these elements increases as you go down the group. So guys, as you come down this way, it gets more reactive. So which one of the alkali metals is the most reactive? Francium. Okay, which one is the least? Lithium would be the least. Okay, we're going to put sodium, at the end of class I'll put a chunk of sodium in water and see what happens. It's still very, very reactive. But again, as you come down this way, it even gets more reactive. Okay, here's a picture of potassium. This chunk right here is a chunk of potassium. They have to store it in kerosene because it reacts with water. Even the water in the air it will react with, the humidity in the air. Okay, let's go to group 2. Group 2 are called the alkaline earth metals. And they have 2 valence electrons. I think you need to fill that out in your notes, right? Okay, they're less reactive than the alkali metals, but they're still pretty reactive. They're never found by themselves or pure in nature. And again, it's because they're very reactive. They're going to try and form a bond with somebody on the periodic table so that they can obey the octet rule. Let's talk about why they're called the alkaline earth metals. Alkaline means basic. It's the opposite of acidic. Common bases include salts of these metals. Calcium and magnesium form the metal in the salt of basic compounds. So that's why they're called the alkaline earth metals. Okay, let's talk about the metals in general. This is a very important slide. I'm going to test you on all 5 properties of metals. So here we go. Please pay attention to this. Metals are good conductors of heat and electricity. You've got to know that. They are good conductors of heat and electricity. So what that means is that heat passes through metals very easily. So does electricity. We use copper in our electrical wires. Copper is a metal. It allows electrons to flow through it very easily with small resistance. Okay, metals are malleable. I want to talk about what malleable means. Malleable means like if you had a hammer and you had a chunk of metal and you got it really hot, could you shape that metal? You could. That's what malleable means. If you hammered it down, could you get this into thin sheets of metal? Yeah, like aluminum foil, right? King Tut, this is not pure gold right here. They just used a little bit of gold foil and plastered it over the top. And that's how they got it to look like that. So metals are very malleable, which means you can hammer them into thin sheets. Okay? You can shape them. Number 3, metals are ductile. Let's talk about what ductile means. Ductile means that you can shape metals into and draw them into thin wire. So you can roll them in, draw them out into big long strands of wire. Think about electrical wire. It's made of copper. Copper, they heat it up and they roll it into long strands of wire and draw them out. And that's what ductile means. Okay, number 4. Metals have very high tensile strength. So high tensile strength. Here's an example of that. If you have an iron bar here, can you just grab it and break it? No, it's very strong. It means it has very high tensile strength. So they're very strong substances. Metals are. Okay, and then finally, metals have luster. Luster means they're very shiny. If you clean them up, polish them, they're going to shine. Most metals are very shiny or have luster. So those are the 5 properties of metals. Good conductors of heat and electricity. They're malleable, they're ductile, they have high tensile strength, and they have high luster. So let's see if we got that. Will, what does malleable mean?
Ability to flatten it?
Yeah, ability to flatten it or hammer it into thin sheets, right? Yeah, you get it hot, you can hammer it down into thin sheets. Okay, Jamin, what does ductile mean?
Like I make it into wire.
Yeah, you can draw it out into long strands of wire, right? Good job. All right, now let's go into the transition metals. The transition metals are the elements in groups 3 through 12. I just got a couple examples here, but there's a lot of different elements there. But copper, Cu, is a transition metal. It's found over here. Okay, there's copper. We use it a lot for a lot of different things, a lot of different reasons. Okay, let's talk about another one that's kind of cool. Mercury. Mercury is the only metal that exists as a liquid at room temperature. It's kind of cool to play with, although it's very toxic, and nobody is supposed to be touching it or playing with it anymore, since we know that it's very toxic. Okay, the transition metals. Let me bring your attention to this right here. Look at where copper is. What's below it? Silver. What's below it? Gold. Copper, silver, and gold. Some of the most valuable metals on the planet. Okay, and they're all in the same group on the periodic table. They're all in the same group. Okay, let's go to the metalloids. Metalloids are found along the bold staircase. We said if they're touching it, we're going to consider it a metalloid. But it gets a little more specific than that. Here are the metalloids. They have properties of both metals and nonmetals. So can they conduct heat and electricity? Mm-hmm. Yeah, but as good as a metal? No. So they can a little bit, but not as good as the metals. Okay, they're more brittle than the metals. They're not as strong. They will break easier. They're semiconductors. Guys, what's a semiconductor? Yeah, it can, but it kind of doesn't at the same time, right? Kind of does and kind of doesn't. That's an important property. And we're going to talk about this element here in just a second, silicon. Okay, and then some metalloids possess metallic luster, some don't. Some are shiny, some kind of aren't. Let's go to the most famous metalloid, silicon. So silicon does have luster. It's brittle, like a nonmetal. And it's a semiconductor of electricity. Which means it can kind of conduct electricity, kind of not. Okay, the other metalloids are boron, germanium, arsenic, antimony, and tellurium. Okay, well let's focus on silicon. Okay. In California, there's a region in California called Silicon Valley. Right?
I've heard of it.
You've heard of it. Why is it called Silicon Valley?
I don't know. That's where they make computers and crap?
Good. That's like the headquarters of the world for the computer industry, technology. Apple was founded there. IBM, Facebook, Instagram, Twitter, all the social media sites have their headquarters in Silicon Valley. Why? Guys, why do they call it Silicon Valley? Yeah. What is this right here? Yeah, computer chip, processor. What's it made out of? Silicon. How come? It's a semiconductor. It conducts electricity, but not as well as the metals. It's just it's an element with good properties for computer chips and processors like that. And so they call that place in California Silicon Valley because that's where a lot of computer and technology companies are headquartered. And a lot of the silicon that's mined and produced in the world goes into building computers. So, okay, nonmetals. We're almost done here, so we got a couple more. Nonmetals are poor conductors of heat and electricity, which means heat and electricity can't really pass through them all that easily. They're good insulators. They tend to be brittle. Can you break them? Yeah. For example, the lead in your pencil, I know we call it lead, but is it really lead? No, it's called graphite. Graphite is made of carbon. Can you take one of those pieces of lead and break it pretty easily? Yeah, I mean, it's very brittle. Okay, they're brittle. Many nonmetals are gas at room temperature, but not all of them. Okay, is carbon a gas at room temperature? No. Is nitrogen? Yes, oxygen is. So not all of them are gases at room temperature, but a lot of them are. Okay, carbon, the graphite in your pencil lead is an example of a non-metallic element. Yeah. I've got some examples of the non-metals here. This is sulfur, what sulfur looks like. Sulfur is known as, what was once known as brimstone. Okay, so in the Bible you'll read a lot about brimstone. Okay? Yeah, it's and in Shrek, I guess.
Yeah, when they're walking in, Shrek's like, oh, our donkey's like, oh. She just
Almost done, stick with me. All right, and phosphorus is a nonmetal. Let's go through a couple more. Graphite is not the only pure form of carbon. Guys, what is this right here? Yeah, it's known as one of the biggest diamonds in the world is the Hope diamond. What element makes up a diamond? Carbon. But we just said that the graphite in your pencil is made of carbon.
So I got diamonds to be like.
It's made of the same element. But what's the difference? Well, carbon in a diamond forms 4 other bonds with carbon. In graphite, the carbon forms 3 other bonds with other carbon atoms. So it's how they're arranged, how they form bonds with other carbons. Okay, halogens. I think you're supposed to write something here. Group 17. How many valence do they have? They all have 7 valence electrons. Halogens are never found by themselves in nature. They're always with somebody else because they're very reactive. They have 7. How many do they want? How many valence do they want? 8. So they're just looking to pick up 1 electron from somebody. Okay, here's a cool, something cool to think about. Halogens in their pure form are diatomic. Guys, what does di mean?
Two.
It means two. And atomic means two atoms. So they're always looking to form a bond with themselves. Let me show you and see if I can help you make sense of this. Fluorine. If we draw its dot structure, how many dots are you going to draw around it? 7. So let's do that. 1, 2, 3, 4, 5, 6, and 7. Well, it says it's diatomic, which means it forms a bond with itself. So another fluorine comes along. It's got how many? 7. 1, 2, 3, 4, 5. Can I put more than 2 on one side? Nope. 6 and 7. Now there's the dot structure for both of them. Does this fluorine seem like it has 8? It's going to feel like it has 8 valence. It's obeying the octet rule. What about this fluorine?
Yeah.
It feels like it has 8. So that's why these halogens like to form bonds with themselves, because they can bond together and share those electrons there, and it feels like they're obeying the octet rule. Okay, that's not only for fluorine, but chlorine, bromine, and iodine also do that. Okay. Here's an example of a halogen. This is chlorine. So Cl2 is a gas. It's kind of this yellow-green. It's a very poisonous gas. If you breathe that in, you will die.
Is that what they put in the pool?
No.
What did they
Not
put in the
very good.
pool?
Not pure chlorine.
But they do put chlorine.
Yeah, chlorine bonded to somebody else.
Okay.
It's a little safer. Salt, the table salt, right? Salt that we eat is called sodium chloride. It's got chlorine in it, but does it kill us?
Yes.
Nope.
Too much
Nope. So that's what's interesting about chemistry. If it forms a bond with somebody else, it kind of changes its properties a lot. Its chemical properties change quite a bit. Okay, let's talk about the final family on the periodic table of noble gases. Group 18. They have 8 valence, except for which one?
Helium.
Helium only has 2. The noble gases are only found pure in nature, which means they're only found by themselves. They're chemically unreactive. They already have their valence electrons. They don't want to share. They don't want to give any electrons to anyone else, and they don't want to take any from anyone else. Okay, they're colorless. They're odorless. And unreactive. And so because of this, they were among the last of the elements to be discovered. Think about it. It would be hard to discover an element that you can't smell, it doesn't have any color, and it doesn't react with anybody. These were some of the last ones to be discovered on the periodic table. Okay, I'm going to end with 2 quick slides here. Let's talk about the group number and valence electrons. Group 1 has 1 valence electron. So all of these guys have 1 valence electron. Group 2 has 2 valence electrons. You skip 3 through 12 because they drop down to a lower energy level anyway. Groups 13 through 18 have the group number minus 10. So this is group number 13. So 13 minus 10 is 3, 4, 5, 6, 7, and 8. Except for this one has 2 valence electrons. Okay, and finally this slide here shows the electron dot structures. Everyone in group 1, 1 dot. Group 2 has 2 dots. And then all the way across. Okay, guys, good news. You've learned enough to do a worksheet in your student workbook. Hey, please listen for a second. So please open up your student workbooks. Let's turn to periodic table worksheet. Be careful with this one. This is 4 pages long, this worksheet. So you know enough to do it. I think it's a pretty easy worksheet. So please go there. Again, it's called the periodic table worksheet, and hopefully this video helps you.